Quadratics always have two solutions, and these two solutions are linked to the graph of y equals the quadratic expression. Whether the quadratic crosses, touches, or misses the x-axis has a lot to do with the coefficients a, b, and c. The discriminant is found evaluating b squared minus 4ac. If it's positive, the quadratic graph crosses the x-axis twice, therefore the quadratic equation has two real solutions. If this is 0, it touches at one point only, and if the discriminant is negative, it doesn't cross the x-axis. For example, the quadratic equation x squared minus 2 equals 0 has discriminant 0 squared minus 4 times 1 times negative 2. Since 8 is positive, the equation has two real distinct roots. These are the x-intercepts of the parabola y equals x squared minus 2. In this second equation, x squared minus 4x plus 4 equals 0, the discriminant b squared minus 4ac is 0. The equation has one real repeated root. The graph of the parabola touches the x-axis at one point only. Notice that x squared minus 4x plus 4 is a perfect square. That is the reason why the quadratic touches the x-axis. The graph of y equals x minus 2 squared is the same that the graph of y equals x squared shifted 2 units to the right. This third quadratic equation, x squared plus 5 equals 0, has a negative discriminant. The equation has no real roots because the parabola doesn't cross the x-axis. This is an interesting question. The quadratic is a perfect square, so we need to find the values of m. Because the quadratic is a perfect square, we know that the discriminant b squared minus 4ac is 0. Replacing a with m plus 1, b with m minus 2, and c with 2, we end up with the equation m minus 2 squared minus 4 times m plus 1 times 2 equals 0. We expand and simplify by collecting like terms. This leads to the quadratic m squared minus 12m minus 4 equals 0, and we need to solve for m. We use the quadratic formula where a equals 1, b equals negative 12, and c equals negative 4. The discriminant 160 can be split into 16 times 10, which leads to 4 square root of 10. The values of m are 6 plus 2 times the square root of 10 and 6 minus 2 times the square root of 10. Either of those values will return a perfect square. Last, the equation has two real roots. Find the range of possible values for m. Since this equation has two real roots, the discriminant must be positive. This means that m squared minus 4 times 1 must be more than 0, so solving m squared more than 4 leads to m less than negative 2 or m more than 2, the range of possible values for m. In our next video, we'll learn in detail how to solve an inequation like this one. Stay tuned! Want more practice? Access full courses, quizzes, and worksheets in the link below. Happy learning!